Okay, what I was trying to remember a few minutes ago was this right here. So I was trying to explain the use of the arrow operator. It's non-intuitive and it's a new thing to potentially many of us. I've just learned to recognize this error, this pointer type error. Uh, indi- that error indicates you need to use the arrow operator, this thing called the arrow operator. Um, but the alternative syntax that we just showed right here, dereferencing the pointer to A, assuming that the pointer to A has been declared and set to the address of the variable A, dereferencing operator prints it's you could call it the contents of operator, the contents of a particular memory address. I've heard it referred to in this way before. So similarly to this, we could dereference. I could say cout first dot link, and we can dereference first dot link. And in this case, there's some business with the order of operations that forces us to use a parentheses before we can't type. You may think that we could type this, but the order of operations in C++ is such that we need to use parentheses here. And just as a reminder, a visual reminder is best. First contains 42, the data 42, and second contains the data -23, these two integers. First, if we want to add some text here, the link contain is an address of the second node. It points to the second node. So that's what we're looking at here. So we could just say second.data, but if we want to iterate through a linked list, we don't want to say second.data, third.data, fourth.data, etc. That's not a very nice, that wouldn't be very, that's kind of like not using a loop uh, and printing the elements of an array, like the array at the ith position. Uh, you would have to say array, print the array contents at position 0, array contents at position 1, etc., etc., 1, 2, 3, on and on. That's not a very pleasant way, but instead we can hop through a linked list in this way. We're going to see three instances of the same thing here. The data contained in the second node is -23. So when we run this program, I have 3 print lines, 1, 2, 3. And we're going to see negative. There's 3 different ways of printing the contents of the second node, which, as we know from this picture, is -23. Okay, we could go ahead and add a third node. Create a third node, and third dot link is going to be equal to the null pointer, the 0 address, because what we're doing is adding a third node, just rearranging this. Is the third node. It points, there is nothing after the third node. So now we've got 1, 2, 3 nodes, and maybe this node contains 76 as its information. Okay, so third dot data equals 76. And now we need to update seconds link. Seconds link is initialized to null pointer, so we want it now to point to the address of third after we've made the third, of course, the third node. And if you would like, we can change these to node, first node dot data, But I'll just leave it at first, second, third here. I don't think it's terribly confusing even when we're just learning this stuff. So now if we want to print third dot data, this is one way to do it, but another way to do it is to say first dot link, arrow link rather, because that is the link. The link is a pointer type. So for pointer types, we don't use the dot operator, we use the arrow operator. And that has to do with the order of operations that I am referring to here. They created the arrow operator for that purpose. And arrow data. I guess I'm not going to try to explain it. I'll just say this is the way to do it. So first's link is second, the address of the second. Second's link is the address of the third. And the address of the third is a pointer type, and we use the arrow operator to access the data. So what are we going to print in this case? If we just print third dot data, first dot link, arrow data. And first is an object. It's not a pointer type. If I change this to a pointer type, then I would have to be saying first arrow link. And then other problems occur. There are two different ways to write to deal with this linked list class. Okay, so what are we going to see here? 76 and 76. Okay. So that's what I do in these first few slides. We have not yet made a link. We have made a linked list consisting of 3 nodes. We haven't written a linked list class. We could, and it wouldn't be terribly difficult to do. Adding a second node object. I've done this previously. I do point out disadvantages of linked lists compared to arrays. You need arrays just consist of data, like this box right here. Linked lists consist of nodes, so they have both the data and the address of the next link in the list. In the case that you're using a doubly linked list, which has some certain advantages that we might get into, there's a link called previous, the previous link, link to previous node, or more specifically, address of previous node. Address of the previous node. It's often just abbreviated as previous, and this is often called next. But we're just calling it link in these cases, in the case of a singly linked list. These are good things to be aware of, the relative speeds of heap memory allocation. You can see this, and I have tested this before. It's neat to see, but I'm not going to get into that in this video. So let's look at an example linked list. I have a quiz that is similar. I snipped this out of a textbook. So instead of the member variable name data, which I think I did up here, data is analogous to this info, but I'm still using link. The head, this 2000 here is the memory address. It's 0x2000, 0x2800, and note that these are not contiguous. They're not touching one another. If this is an integer type, which is running from 2000 to 2003, if your memory is in bytes, these are memory addresses, but it's not contiguous, not touching one another. So can we ask ourselves these questions? The head of the list is at the address 2000. So what is head arrow info? Without just looking at the answer here, the info contained by the head node is 17. So what about head arrow link arrow info? So head's link points to the memory address 2800, which is here. Head arrow link arrow info is the value 92. Just to add another example, let me add it in Notepad so I'm not changing my Notepad. What happens if we write head arrow link arrow link arrow info, or arrow link? Sure. What is this going to be? It's going to be a pointer, but link. So head arrow link is 2800. Arrow link is 1500. Arrow link is 3600. Okay, so if we were to add, this is equal to the memory address 3600, which is probably a hexadecimal memory address. Although maybe it's, well, it's not binary, but maybe it's base 8. I forget how octal is represented in memory. But that's equal to 0x3 3600. The same thing with an arrow with an info at the end of it is the info contained in that node, which is 45. And we could write a program that makes this linked list doing something similar to what we have done right here. Okay. I don't think there's anything terribly new here. Yeah, now here is a nice thing to demonstrate. So let's demonstrate that. What happens if we say link, link, and how many links are in our chain right now? We had 3 nodes. Yeah, 3 nodes. So 3 nodes are connected by 2 links. 1, 2, and we also have a link to the null pointer. So we can print the null pointer here. So let's do that first. First arrow link. First arrow link is the address of the second node. Arrow link is the address of the third node. Arrow link is the address, the null pointer. So link, link, link. So 3 links. But what happens? We'll see in a minute what happens when we step beyond the third link, the null link, which links to nothing. So that's the null pointer. All right. Just like we've shown here. And it is the null pointer because I set third arrow link to null pointer. If I instead, if I wanted to make this a circularly linked list, if I wanted to point this back at first, like that could be described as a circularly linked list. So third arrow, third dot link. I keep on saying arrow because I'm used to making these pointers, in which case we would say third arrow link. But for now, I guess I'm avoiding that notation. So we got null pointer printed, the zeros, earlier because I set this to null pointer. I could make a circularly linked list and set this equal to the address of first. That is a legal thing to do. So now when I print this, if I also print cout the address of first, we're going to see 2 lines of output matching each other. AB8, AB8. Okay. But we're not getting into circularly linked lists. There are some nice uses of them, but I don't really get into them in my class. Just trying to keep it simple. Not simple, but not cover all of the things that are possible to cover in a data structures class. But yeah, what happens if we step beyond the null pointer? What happens? And it's very likely you'll see this error whenever you are playing with linked list. Read access violation. Link arrow link was the null pointer, so you can't step beyond null pointer doesn't point to, it doesn't have a link. null pointer is not a class object for which the variable link is defined. Okay. So fully expect to see that error occur again. We step one position too far. So what about these things? Current, so current is usually used as an analogous entity to a loop counter variable like the loop counter I in this case. Current is going to be our link counter variable, so to speak. It keeps track of where we are in the linked list. So current is the memory address 2800. It points to, there's a pointer, it's a pointer type member variable. It's a current node whose link is pointing to 2800. It contains 2800. Okay, so what if we say current arrow info? That is 92. Current arrow link is 1500. Link is 3600. Current arrow link. And head, we'll need to get comfortable with this language when we're writing linked lists and writing algorithms for linked lists. So head, arrow link, arrow info. Head, arrow link is 2800. Arrow link is 1500. Arrow info is 63. So link info link, that's interesting to think about. Current arrow link, arrow info. Does info, let's just think about it. Current arrow link. Okay, so that's 1500. Arrow info, that's 63. So does info is just an integer. It's this value 63. Does it have a member variable named link? Is it an object? It is not. And we could demonstrate that with this code that we've written. So let's say first arrow link, arrow info, arrow link. Okay, there's an error. Node has no member info. Excuse me, I should say data. I'm mixing up my variable names. Data. Okay, but this is also going to be an error. The operator arrow was applied to an integer instead of a pointer type. Okay. Yeah, so all right. That's a good error to be aware of as well. That's the null pointer right now. And what's this other error? The link does not exist in this case. Current arrow link. So current arrow link 1500, arrow link 3600. Arrow link is the null pointer. That's what the 0 means in this diagram that I took. So the null pointer does not link to info. Let's do something like this. We're going to get this except data. Sorry. We get an exception again. This was null pointer, so we have stepped one link too far along the chain. But if you remove this link here, link first dot link arrow data, that's going to be the data of the third node. $76. Yeah, and that's how we set it. So 76. Okay. This is a decent stopping point. It's where I stop and let me delete this old assignment. Quiz 2, part 1, I think is an assignment that I still have. So the quiz gets students some familiarity with this type of lingo for linked lists. I show some diagrams and ask questions like, what is the value of this? what's the value of this thing, what's the value of this thing, and so on. But let's see, next time, start using node pointers and make a linked list class, and we'll write some member functions. So writing our own linked list class. A linked list class does exist. In fact, two of them exist in the standard library. There's a list, and then there's so that's a doubly linked list, and pound include forward list is an example of a singly linked list. But we're going to write our own just so we get some nicer insights into algorithms and data structures.